Welcome to The Explainer. Today, we are pulling back the curtain on the hidden architecture of digital law. We're talking about the legal DOM. Think of our visual setup today as a giant whiteboard where we're going to map out the ultimate bridge between static text and programmatic action. We're literally looking at how the very rules governing our society get transformed from dead ink on a page into living, executable data. It's absolutely fascinating stuff. Let's just hook right into the core tension here. How on earth do we make complex legal text computable without completely breaking it? Look, if a clumsy text editor or, a hallucinating AI scrambles the underlying structure of a statute or digital contract, it's not just a weird glitch on a web page, it's a legal disaster. The rules of society demand absolutely exact fidelity. So, how do we safely interact with and manipulate this highly sensitive text? Section 1, Declarative versus Imperative Paradigms. To start untangling this, we really need to draw a stark line between two completely opposite forces in computing. Think of this like the difference between an architect's blueprint and the builder actually swinging the hammer. On one side, you have the declarative state. This is your static markup, things like HTML or XML. It defines exactly what the content is, setting up a rigid, static schema. It doesn't actually do anything, it just is. Then, in stark contrast, you have imperative execution. In modern web interfaces, this is mostly JavaScript. This procedural code acts as the active builder, defining exactly how that static content should dynamically change, react, and execute. This dynamic actually perfectly illustrates something digital humanist Alan Renier pointed out a long time ago. He contrasted descriptive markup, which basically just indicates the logical state of the content, against procedural markup, which barks out specific formatting commands. By strictly separating the what from the how, computer scientists essentially cracked the code on turning ambiguous human language into a highly structured, machine-readable meta-language. Moving on to Section 2, the document object model. Now, for any of this to actually be useful, these two opposing forces have to talk to each other. We need a bridge. Enter the document object model, or DOM. This is the physical construction site where our static declarative blueprint and our dynamic imperative builder finally meet up. So what is it? The DOM is an in-memory, language-independent programming interface. When a system loads up a document, it doesn't just stare at a flat wall of text. It conceptualizes the whole thing as a hierarchical tree structure. It's almost like building a digital family tree out of every single paragraph and period. Let's pop the hood and look at the mechanics here. First, the DOM parses HTML or XML into that logical tree we just mentioned. Every paragraph, every bolded word, it's all brought to life as a programmable node object, which inherits properties from specific APIs. And this is the magic part. It allows your imperative scripts to dynamically mutate the state of the document. Because these native interfaces act as live objects, any mutation syncs instantly. By representing document elements as nested programmable objects, the DOM creates a highly deterministic environment. Suddenly, text nodes aren't just text, they're concrete, executable items. Section 3, applying DOM to the law. Okay, let's take this bridge and apply it to arguably the highest stakes text we have. As we transition legal documents from paper prose to computational data, the requirements are, as you'd expect, incredibly strict. We're talking intense XML validation using standards like the Aquamontoso schema, which is a specialized global language built just for parliamentary documents. But why go to all this trouble? Well, we have to mitigate what scholars call moral crumple zones. That's when humans end up absorbing the damage of probabilistic machine errors. Think about it. If this code breaks, real people suffer real-world consequences. The law demands absolutely deterministic, exact mathematical fidelity. Which brings us to Section 4, the BY-DOM synchronization pattern. Here is the million-dollar question. If legal XML is so unbelievably rigid, how do we let humans naturally draft and edit laws in a web browser without shattering the entire mathematical system? The solution is an absolute architectural masterpiece called the BY-DOM synchronization pattern. Basically, instead of forcing humans to edit raw, fragile XML directly, the system maintains two separate document trees in the browser's memory at the exact same time. First, you have the editor DOM. This is a lightweight, intuitive HTML interface that the user actually sees and modifies. Then, hiding in the background, you have the store DOM. This is the structurally rigid, schema-validated XML that holds the absolute structural truth. Let's walk through how this capture process actually plays out. It relies on an invisible middleman called the edit capture extension. Step 1, the user types a new clause into the visual editor DOM. Step 2, this extension instantly grabs those exact differences and encodes them into a hierarchical coordinate format, completely ignoring the visual layout. Step 3, those precise coordinate changes are seamlessly and securely pushed into the rigid XML store DOM in the background. This decoupled mechanism is just brilliant because it ensures lightning-fast performance while keeping the core data utterly pristine. It allows for optimizations like group steps, where massive structural shifts, say globally renumbering an entire legal code, are compiled into a single undo/redo action. It also uses neat tricks like editing islands, where it only loads the exact tiny segment of the law you're actively tweaking. That keeps your browser from crashing under the weight of massive statutes, and it completely prevents the screen from flickering when multiple lawmakers are collaborating at the same time. Section 5. The Future of Computable Law. As we start to wrap up this explainer, let's zoom out and look at how this formalization enables the true rules-as-code movement. We're no longer just formatting documents. We're literally engineering semantic legal architectures. Because we've isolated the legal DOM so perfectly, we can start attaching some incredibly powerful downstream systems to it. We're using HTTP-based resolvers to create smart hyperlinks across different statutes. We're plugging in temporal version control engines that dynamically evaluate citations based on historical context, meaning you can instantly recreate the exact state of a law on any specific date in the past. And over in private contracting, human-readable templates like template mark can automatically convert into structured data, or agreement mark to power self-executing smart contracts. Ultimately, this highly structured legal DOM acts as what we can call a sovereign gate. In an era where AI is constantly generating endless approximations and guesses, this framework uses imperative text scripts to assert absolute human intent. It strictly bounds the error space of probabilistic machines. It basically ensures that the hardware executes exactly, and I mean exactly, what was designed by the human author, maintaining our legal and moral safety. So, I want to leave you with a final thought to chew on regarding your own role as a steward of the machine. In a world increasingly run by massive, lossy statistical engines, will you actively use the legal DOM and structured text to build true deterministic fidelity into our digital systems? Or are we going to let probabilistic noise take control of our most important societal rules? The choice of how we build our legal infrastructure is entirely up to us. Thanks for joining me on this explainer, and keep learning.